So again, appreciate everyone joining us today. I'm gonna let the panelists introduce themselves. My name is Michael Brennan. I'm with Entech Engineering, Business Development, and I will be moderating today. And I will have a few polls that I will share with everyone to get some feedback on the audience on their cares and concerns in regards to humidity. So I'll turn over to Stuart Heisey.
Hi, everybody. I'm Stuart Heisey, principal at Entech Engineering. And, we obviously deal a lot with trying to solve humidity issues on existing buildings and making sure that we don't have them on new ones that we're working on. So I'll be giving that perspective on it. I'm going to hand it off to Neal.
Hey everybody, good afternoon. I'm Neal McNutt. I work for Penn State Office of Physical Plant for a small division called Commonwealth Services. So we're a group of about 10, 11 people that travel around the state and handle the Commonwealth campus issues. I primarily am working with housing and food service projects.
Bill Leech. I'm interim director with Facilities Project Services at Kutztown University, and we are a 150-year-old facility. So needless to say, we have our issues with buildings. Yes.
I'm Ray Alexandar. I also work for Penn State Office of Physical Plant. I'm a facility engineer, and I kind of serve like a portion. The campus is divided up into 6 areas, and I'm an engineer that serves one of those areas, primarily consisting of lab buildings and housing.
And Dakota.
My name is Dakota Brown. I'm the service manager for Dual Temp Company. We're a mechanical contractor out of Allentown, Pennsylvania. We serve the eastern half of the state and western New Jersey, and we do all commercial, industrial, institutional spaces in that territory.
Appreciate it. Well, thank you everyone again. So yeah, we're going to start off with a poll. I'm going to launch this now, get some feedback. So how many times have you had to deal with humidity issues in your buildings? So either never, sometimes, frequently, or every summer. So we're going to give this about, watching the votes come in, give it about, I don't know, 30 seconds or so. All right. Can you guys see the poll results here?
No.
Or is it displayed for you all? Okay. Well, I'll go through it real quick. So I have sometimes, oh wait, there we go. Hold on. Share results. Sometimes, frequently, and every summer. So we got a little bit of a mix there, but never is not one of them.
Never was not one of them. Yeah.
All right. So I appreciate that. So let's get into the first question. What was, and anyone can answer this, feel free to jump in. What was your worst humidity related project and why?
Okay, I'm up. Can I go? Okay. So like I mentioned, 150-year-old campus, a lot of old buildings. We have mold issues. We have tons of issues, but we had one particular building that housed faculty. And in this particular building, we had an opportunity to do a renovation. And we did a renovation of the HVAC system, but they really ripped out fan cooler units and put 4-pipe system back in with fan cooler units. Outside air directed from the outside into each fan cooler unit. Probably looking back, not the right application, the direction to go. Spent about $1 million on that renovation. Continued to have humidity issues. We had no reheats. We had no method. We had no method of getting rid of humidity, especially on those ridiculous days. So we ended up going back, throwing another, I don't know, 250,000 at it to add DUs above the ceiling in the corridors, like 5 kW or 8 kW reheats in the corridors to heat up that corridor plenum air. That has appeared to take care of the problem on the first floor. We're yet to do that on the second floor, so that'll be another $500,000 that we're throwing at this bad choice for a system. So,
and Bill,
so
where's the ventilation air introduced for that system? Through the fan coils?
Through the fan coils, yes.
Yep.
Yes.
Not surprising.
No, and so you had mentioned DeFrancesco, which had a similar scenario, and we have since wiped the slate clean on that project, and we're approaching with a centralized VAV system with, and whatever you do in future designs, everybody who's listening, please don't shortchange yourself on reheats. Do not. Put them in every VAV box. Don't shortchange yourself. So, okay.
Yeah, thank you, Bill. Anyone have anything to add to that one?
We've had a couple of, it depends, what side you want to look at. If you look at production side of our business, because we do in the service department, we work on, production facilities, we work on office spaces, schools, all that. And in production, something we've seen a lot of is if we're doing, an ISO clean room and they're looking for specific air changes, depending on the original design, they may have been handling that with the air handler that's also providing the cooling for the space, or they were handling the air changes with the HEPAs. And sometimes they'll oversize the equipment to get the air changes, but then the cooling is also oversized. So now you have a problem where the humidity is really high. Or in that same vein, the usage has changed. So they originally were going to have it be, an ISO 7 clean room, and they were going to have all these pieces of equipment and they were going to generate heat. Well, now they changed it. Now it's just going to be an ISO 7 clean room, but it's going to be packaging. So all that heat generating equipment's gone. So now they don't have the heat load. Now the equipment's oversized. And now it's 80% humidity in there. So then we have to go, like Bill was talking about with reheats for heat, that's an occupancy kind of thing. But now we have to put in SCR control, electric reheats, and try to do something for dehumidification. That's one option. I mean, there's tons of options at that point, but it's through no fault to the design engineer. It's through no fault to us as the mechanical contractor. It's a clean room that was designed for this, and now it's being used for this.
Yep.
And that's a difficult one.
Yep, that is.
And we see change of use is often one of the triggers that lets you realize your system's not as flexible on turn down as and first cost limits you to what you can do sometimes. But yep, definitely.
So why should people care about high humidity then? So obviously it's an issue from a comfort standpoint, obviously with the occupants, but besides that, what would be some other reasons that high humidity potentially could be an issue that should be addressed?
Building environment, because it's going to lead to problems. It's going to lead to problems. It's going to lead to little green areas that show up on ceilings, and
Yep.
We don't like those. So yeah.
So mold and mildew. So from a health impact, obviously high humidity could lead to that. Is that something that takes a couple of weeks to, does anyone know that for mold or mildew? Or is that a longer process of just going through the cycles?
For it to grow or to get rid of it?
To grow.
I guess it depends on the building and how bad it is. We've seen places where they've had high humidity issues, and we go and say, okay, well, this would be a solution. Well, we don't have the budget for that. Okay, well, here's another solution. Okay, you're getting closer. And then we finally, work within their budget, come up with a solution. We don't get mold in that. And that might have taken 2-3 months. We have other places where we're doing regular maintenance. We had one recently. It was an IT room for a bank, nothing fancy, mini split. We're there quarterly. And our guys take pictures and videos every time they're there. I'm here at this customer site. This is what we're doing. Last time we were there, everything was fine. We go there this time, the room's full of mold. The equipment's full of mold, the room's full of mold, everything. We were just there 2.5-3 months ago. So it depends really.
Yeah. I mean, how high the humidity gets, obviously all those things are organisms. They like to grow with food. So if they have a good food source on the surfaces that they're dealing with, that changes how quickly it can happen. So yeah, lots of things to play in. I'm going to do a quick screen share of the why. You ask why, Mike, and this is from ASHRAE, some studies that were done on different types of reasons why we pay attention to humidity. And when you look at this, and we're not going to talk today about low humidity particularly, but low humidity does have issues in buildings. But we've dealt with low humidity and experienced that in a different way than the high humidity issues that are more likely to damage the building infrastructure. So, there's a reason why you get outside of that sweet spot. On the high humidity side, like I said, is where you have a lot of the things that can begin to impact the building's longevity, the materials in the building. So that's why it's really heavily guarded against. But there's also some really good arguments against allowing buildings to get too dry in the wintertime, primarily in our region. And so we oftentimes add humidification into systems Every once in a while, it's not really common, but every once in a while, those humidification systems end up humidifying when you don't want them to. And certainly those systems take first cost dollars, they take operational dollars, they take maintenance time. There are all kinds of reasons why we don't necessarily put them in every system. So, but yeah, there's the reasons. I mean, fundamentally, that's the reason why we care about humidity, right?
Yeah, absolutely.
Yeah, if I can interject, that's a good segue into some of the biggest issues that I've run into with humidification. And it is in the winter. We have spaces, again, I work at Penn State, and we have some lab spaces that require minimum humidification. Some of them are as high as 50% relative humidity. And in our climate, you have to have a really good building envelope in order not to condense on the exterior wall. And my office is in a $250 million facility that was built about 10 years ago, and we have issues. Any of the spaces that are humidified that have an exterior wall, we had to lower the humidity on humidification levels when it gets really cold out, or we condense and then we start dripping, out at the windows. The spaces that work the best are the ones that are interior to the building. We have a vivarium space that does have exterior walls, and it's constructed entirely of fiberglass panels and epoxy paint. Every precaution is taken, and that space performs well. We also have a clean room, and it's interior to the building, so there's corridors or offices surrounding it around the exterior, and it's at 50% relative humidity, and it does well. It performs well, and we don't have condensation issues, but we have them elsewhere in the building. And they went through, they re-insulated, they treated, they did everything they could, and it is a difficult thing in this climate. If you're trying to maintain over 30% relative humidity, you better have your ducks in a row, because it's really hard not to destroy an exterior of a building with trying to humidify in the winter in our climate.
What could be some of those keep your ducks in a row? If someone is looking at doing a new building or a major renovation, to making sure that they are keeping humidity levels at whatever the desired level should be. I mean, obviously an envelope that is not leaky, but what are some other maybe system related?
Yeah. Yeah, you have to have, good air distribution, good airflow. You have to have a good vapor barrier. You have to watch anywhere there's thermal shunts through the exterior, steel coming through the roof.
Yep.
That's a good place for dripping to occur. Like I said, I really think in our climate, unless you go to the extreme of the fiberglass paneling instead of drywall, you need to keep the humidified spaces to the interior of the building and not have exterior surfaces next to the humidified area. Because like I said, we had a consultant that was just looking at the exterior surfaces, and it's still, the building performs pretty well, but when we get a really cold snap in the winter, you don't notice anything. It isn't until it warms up and wherever that moisture went and froze, it starts thawing, and then it starts dripping down in the windows. So what we do is we track the humidification with the outdoor air temperature and back it off when it gets colder out. So you need to be able to have that level of control to prevent that from happening.
Yeah.
The vapor barrier thing is important too, because we've had spaces where they had a heated but not cooled warehouse, and they had the high volume, low speed fans. So the big yellow fans out in the warehouse, and they decided that they weren't happy with the performance of the space because they started getting moisture on surfaces, and they thought that it was because of the ventilation. We were following guidelines for air changes per hour and all that, But it turned out that we were actually getting striping on the concrete from moisture coming up through the ground. Because, I mean, I'm not a concrete guy, I'm an HVAC mechanical guy, but it sounded like the conversation was being had with the concrete contractors and the people who were involved in the site work was that maybe there wasn't a good enough vapor barrier down to keep that moisture from coming straight up through the concrete. So then, you know, they asked us, well, what can we do to condition this and address the humidity? Because the load in there isn't big. It's just an empty warehouse, and they did a good job of constructing it otherwise. So we had to look at, okay, well, if we put in, you know, standard package units, if we do have humidity issues, we could utilize the existing, you know, Cambridge units and the unit heaters that were in there. We could utilize those to create a little bit of false load on those low load days, so we could run our cooling longer to get that latent heat out of the air without overcooling, because we didn't have any sensible load. So it's getting creative with stuff like that.
Yeah, and that brings to mind one of the major mistakes that I see occupants making. I'll say occupants less than facilities folks. It does occasionally happen by the facilities folks too, but occupants think when it's humid that they should drive the space temperature down, and that's never the answer. It'll always make the condition worse. So, you know, that's, to me, that's a huge takeaway. If there's any piece that you get walking away from this, it's that if you have humidity issues in your building, the first thing you should make sure that isn't happening is that your occupants aren't trying to make the space colder. It'll always send it the wrong direction.
Why is that?
Well, I mean, what we're talking about here when we talk about high humidity, we're really talking about relative humidity. And so relative humidity is dependent on temperature. The colder it gets, the same absolute humidity that's in the air increases in relative humidity. So when you think about it from the condensation comments that Ray was making on an exterior envelope, air has a dew point. That dew point is the temperature at which water will condense out of the air. And so you know, if you drive the temperature of the space down, but you don't take humidity out, because you'll never take as much humidity out as you cool down when you're using you know, comfort cooling equipment, you just drive that air closer and closer to being saturated and starting to dump out moisture everywhere it gets a chance to.
That's one of the biggest mistakes we see too. Everybody starts having issues and they crank down the temperature. I'll get my air conditioner to run longer to get it out, but air conditioners only dehumidify as a byproduct of meeting whatever your temperature set point is. And all HVAC equipment has a sensible heat ratio where it can say, okay, well, I can take, you know, 10,000 BTUs and this much of it's going to go towards meeting the temperature set point. This much of it is allowed to go towards taking away the moisture, and whatever's left after that is just wasted energy. It's just destroyed. So it's not a dehumidifier. Most comfort cooling is not going to dehumidify very well.
Yeah, and that's why Bill mentioned earlier about reheat, about not omitting reheat from your building system. Give yourself some way that you can solve a humidity issue. And when Dakota mentioned his warehouse case, they were basically using space heat as reheat for the building. Neal, you're showing us something cool. What you got?
There you go. That's what happens when you just try to drive the temperature down with air conditioning to dehumidify, and it just starts raining inside your facility. So that's a kind of a war story for us as we go around campuses and we try to talk to building managers and educate them on what to do and what not to do. But yeah, if I could show you a couple of pictures of a project that kind of was a nightmare for us, you know, my boss and I, Justin, we go around really just trying to fix problems or improve spaces. We're not building managers at any one campus. And so this was a campus here where we were going in to renovate some restrooms. You can see my screen. And one of the things we're always concerned about for housing folks is that we give them enough time at the end of the construction project to make sure things are clean. And so since the contractor was just going to be working in these quadrants, these 4 quadrants of this stick-built building, we asked them to plastic off these hallways. So they plastic every one of these corridors off and you know, use painter's tape. And so essentially this 103B, 103C, 103D, nobody went in there for the whole summer. And so we thought we were doing right. This was 2 summers ago, so it wasn't 2018 when we had such that wet season, but it was 2019. And stick-built building, it was already under an envelope study because we knew it was negatively pressured. So we had some issues with, the caulking around the windows and door frames, and it was just sucking in air all the time. And then we learned later, after we came across this incident that happened just about 10 days before students returned that fall, we learned later that the exhaust fans were on in this building 24/7. So not only was it negatively pressured, but we're just exacerbating that situation by keeping those exhaust fans on all summer and just pulling in moisture. I'll show you what got sent to me by the building manager. Essentially, we opened up the plastic 10 days before students come back, and you start seeing things like this.
Beautiful.
So pretty nasty, but we had this perfect incubator space where they had PTAC units. I should probably stop sharing this before I get in too much trouble, but you had this perfect incubator space. No one was going in there. PTAC units were set somewhere, I think around 68, 67, and they were just cranking all summer long. The vents were open, pulling in outside air. And it was nothing really that at the time I had thought to preventatively check. It was just, hey, we're putting up plastic, we're keeping this drywall dust out of here, and we're doing right for our customer. So.
And I'll make a quick comment. We talked earlier about when mold and mildew and stuff grows and why, and talked about it needing a food source. I think what you're seeing on your carpet is the mold and mildew imprint of spills that got cleaned up from a visual standpoint. You don't see them, but they're still there. There's still some content in the carpet. That's somebody's spilled coffee cup that got vacuumed up and cleaned up. Didn't look like it was still there, but we found it.
Yeah. So a couple war stories there, but we're currently under a project right now. And, this is not a huge building, but, we're dropping probably about $450,000 to introduce a dedicated outdoor air system. And it's going to have proper ventilation in every room, and just trying to make things right that were not quite set up right years ago.
Hey, Mike, let's hit that one poll that we have about building type. I think you got one that might.
I do.
Some direction here.
It's a good segue. All right. So what space types have been most problematic with humidity? You can select multiples. So we have obviously classroom, residence hall, auditorium, office, and gym space. So again, we'll give this, 30, 45 seconds. See what kind of results we get with this.
We get the most complaints about office buildings for sure. The residence halls, the issues we've had have been construction issues that that's a lot of time, to Ray's point earlier, a lot of times what we're trying to do from an HVAC standpoint is fix a construction issue with an HVAC solution. And if the building had a perfect envelope, it'd be awesome, but it doesn't. So then the HVAC equipment was designed for, certain leakage rates. Our leakage rates are higher, and the building's in negative, and somebody closed the outside air damper on the economizer, and now air is leaking in everywhere, and somebody turned the makeup air unit off. It's a Greek tragedy.
Yeah, I know I've posted some blog materials talking about mechanical systems as a cause for humidity. And I actually was thinking recently, it's not so much that they're a cause, it's just that sometimes they're not designed well to remove the cause, right? You don't generally generate humidity from mechanical systems, but if they're not operated correctly, or if they're not designed to take care of another deficiency in the building adequately, then you can solve the problem sometime with the mechanical systems change. But root cause is really what you want to take care of.
I saw Troy, and glad Troy can join us. It's been a while since I talked to Troy, but he mentioned how obviously on the campuses that residence and office spaces are often vacant during the summertime, unless they have, again, we were talking early on about camps, bringing kids in, but that's a good point that the professors for the most part. They're not in the offices as well, but based on the poll here, 53% office, 41 gym, 35 residents, 18 classroom, and then 12 natatorium. So interesting.
Yeah, the summers when we take time to shampoo the carpets in the dorms.
Uh-huh.
That doesn't help.
That does not help. Nope.
Have you seen a transition in some of your facilities management practices, such as dry cleaning, starting to take hold?
I don't know that we have. I think they're maybe starting to talk about it, but we have realized that fan coil units in the wall where you bring in the outdoor air is just a recipe for disaster.
Yes.
So we're going with more of a, if we use a fan coil, we'll go with a DOAS system coupled with it.
Yeah.
So that helps.
Yeah, it gives you a hammer to take care of humidity.
Yes.
So I have a question that I did not prepare you guys for as panelists. So, and it was one that an Entecher mentioned about asking. He will not be named, but anyways, so in the United States of America, I'll give it multiple choice. What would you think would be the most humid city on an annual basis? So not one particular day, but from an annual basis. And the multiple choice will be Tampa, Houston, Jacksonville, Florida, Orlando, New Orleans, or San Francisco. I'll ask my Entech friend Stu. I'll ask you to go first.
So you listed Tampa and Jacksonville, New Orleans,
Houston and Orlando and San Fran.
Houston,
because I'm
Orlando, and San Fran.
Hmm.
Boy, I'd be hard pressed to go away from one of those three Florida ones, but I'm guessing it's a little bit of a trick question.
No.
I'm gonna pick one of the Florida ones. I'm gonna go with Tampa.
All right, Neal.
Teetering between, the foggy city of San Fran and the mugginess of New Orleans. So I'm gonna split pot there.
Go New Orleans.
Yeah, I'm going New Orleans also.
I say New Orleans as well.
They had more Google time.
I guess so.
I threw it right here. I didn't touch it. I
I'm right here.
No, I saw all the
New
eyes on the screen. There was no
Orleans.
Googling. That's
Yep. So it was. They were slightly ahead of Jacksonville, Florida. At least on my my Google search here. I'm sure there's probably.
and
Very-
at the same time, you look at all the East Coast spaces. I thought you were going to really throw a curveball and put Philadelphia in there, Mike. We spend a lot of time in the summer with high relative humidities in this climate region as well.
That's why I prefaced the annual, because I know that. Yeah.
Yep.
If you look in Philadelphia in July and August, yeah, I'm sure it is probably very high in comparison to some of these other cities as well. But yeah, annual basis. But
And it's the shoulder seasons too that get you, because you have relatively cool days that it's rainy and very humid.
yeah,
When I was a designer, I would try to design my air conditioning systems to be as small as possible, so they worked hard, and they worked hard enough during those in between times to hopefully try to wring out some of the moisture out of the air.
Yep. I know we're right on the cusp of kind of the boundary. The farther north you get and the farther west you get, economizer days increase, but there really aren't a huge number of hours of economizer days in Pennsylvania if you start looking at enthalpy. It's certainly times when it makes sense, and from a code standpoint, we have to design systems with economizer functionality, and it has some good benefits, but also you got to be careful on humidity. A lot of times you can go into economizer and really add a lot of moisture to your building that your systems are not sized to handle, exactly because of what you mentioned, Ray, with being oversized for that temperature condition, but being loaded up on humidity.
A lot of things that we find is that, a mechanical system, I'm speaking as a mechanical contractor, so that's why I keep going that route. But a mechanical system is only as good as how well it was installed and how well it was started up and commissioned. We find a lot of we'll get a nuisance call within a year, right? The building's built, it's turned over, owner training's done. We get these nuisance calls, we go in, we find, and maybe we didn't install it, maybe we did, maybe we had factory startup. It doesn't matter. Everybody makes mistakes, right? And we have a workforce of people who are maybe not as well trained, right? So we'll find enthalpy curves set wrong. We're on the wrong setting. We're bringing in too much outside air, or somebody set the minimum position too high. So it's only it's only going to perform as well as whoever installed it and set it up. So it might be the best design in the entire world, but if somebody didn't set it up properly, you're going to have a ton of issues. And on the flip side, it might be designed properly, installed properly, and commissioned, but then it's not maintained. So we start getting nuisance calls. We get there, the filters are destroyed. The DOAS is tripped because the compressor shut off on low pressure because the filters are so dirty on the outside air, but it's still drawing in outside air, but now it's raw and unconditioned, but the compressor's not running. Now you're dumping all that raw, unconditioned outside air into the space where you just put in $300,000 of VRV, and that air is just dumping into the common areas, and now it's super humid and they can't figure out why. Well, the piece of equipment on the roof that does all your outside air and conditions it is the compressors are off and it's bringing in raw outside air, and it wasn't designed for that. So maintenance is really important too. And we see a lot of places where if they don't have on-site maintenance staff or adequate staffing for their on-site maintenance and facilities people, the equipment's not getting taken care of. And that ends up causing nuisance issues as well, especially for humidity in the summer.
That's good info. Thank you, Dakota. Very, very true. We had a question pop up, pose. So if you have humidity issues, what should be your first steps? So, Mike Brennan calls Entech and said, my building's humid, make it better. What are some of the first steps that can be taken to address, again, those complaints or high humidity?
It's multifaceted. I mean, like Dakota alluded to before, HVAC is only one piece of the pie. What's going on with your building envelope? Did they caulk the weep holes closed because they had bees coming in the building? I mean, do you have 300-year-old trees that fill your gutters so the water comes inside the brick and it can't get out? Is moisture coming in? Are your windows shot? What's leading to this buildup of moisture? If you have a buildup of moisture, is there a reason you have humidity issues that you do? Because HVAC is only going to take care of so much of it. And then you get to a point where, like you said earlier, we're going to be oversized, we're going to be inefficient, and then there's other problems associated with that too. So yeah, a good place to start.
I think one of the best places to start. Go
that?
ahead, Dakota. That's what I was just going to say. Measure.
Data loggers. I don't know why it's blurring it out. Maybe it's copywriting. Zoom knows it's copyrighted.
You got to hold it over your
Data
face.
loggers.
Okay.
I keep these in my office.
There you go.
And anytime that one of my techs comes to me and says, hey, we're having a humidity issue, something doesn't seem right, I grab them out of my drawer, I set them up, I say, go back, throw these in there,
Yep.
put them in this area, we label them, we leave them there for a week or two, we pull them out and we look at the trend.
Yeah.
What's the chart say? When is it humid? What's the dew point look like? What's our temperature? And from there, we have real data that we can say, okay, well, this is what's going on. This is when it's happening. So data loggers are huge for us. We use them all the time.
How much do they cost?
They're not expensive
25, 30, 50 bucks maybe till you get
These
one of
little
those.
guys, they plug right into your computer. No special tool like these ones. These are Supco ones. You need a special tool, and then the window. They're great, but they're a little more cumbersome. These little guys, plug them right inside your computer, set them up. They're cheap.
So what's our data logger? That data logger is going to say, don't have a night setback, right? That's what it's going to say. Oh my God.
Or don't set back very far.
I had an energy guy sitting in the office next to me. You don't want to hear that. You know what I mean? Oh my God, we want to set our building back. But I got a building it's high humidity. Like, no, I don't want to set it back. I want to keep it running. Data logger says I need to keep that system running full out all the time. You know what I mean? So,
Yep.
yeah.
That was a good one. Anyone else have any? So obviously, yeah. So measure is the first step. Any other?
Well, I think, especially coming from a housing and food service perspective, where You've got building managers that aren't always, thinking about the envelope. They're not thinking about the MEP side of things. It's like, hey, get some dehumidifiers going now, whether you're renting them, whether you're buying them, just start, make sure your envelope are your doors open, your windows open, like shut some of those down, because it's probably a July, August situation, and rent some dehumidifiers and just let's start there until we can get on site, or we can get Entech on site, right? Or dual temp on site to check this out and further evaluate. But I thought, Stuart, you were saying the other day that all the presenters and panelists were going to get one of those data loggers. Is that right?
I think you heard that right.
I don't know if
Yeah.
you guys can see this, but I mean, this
Yep.
is this is old data. I did this years ago, but it's not relevant anymore. So I figured it was easy to share. But we could look and we can see what was our temperature, what was our RH doing, that's the blue line, and what was our dew point doing. This is all the way back from 2018. And I don't remember the specific issue here. I know that they were having high humidity. I don't really remember where we went with it, but it's just good. It's just a good tool to have in your toolbox when somebody starts complaining. It's one of the first things we do. You're having humidity issues. All right, well, let's see what your issue actually is, because everybody can complain and say, I'm hot, I'm cold, I feel yucky, it's sweaty in here, it's clammy, whatever. But the data is not going to lie to you.
Right.
And whatever this space was, we talked about relative humidity before. This space is trying to maintain 67 degrees, it looks like. And you really got to dry the air out when you have a space like that. And you do have some spaces that you need to have at that temperature. Medical OR facilities oftentimes want to be real cold. There are some process spaces, clean rooms, some techie type spaces where they're doing stuff where they need cool temperatures in the space, and it requires a different kind of mechanical system to be able to do that when you're ventilating.
You can actually see here on the actual data, they were actually doing pretty good, all things considered. 67 degrees with 58%, or sorry, I was looking at the dew point. Yeah, so you can see during the day, 9:48 a.m., 66 degrees, 73% humidity.
Yep.
If they would have raised that up to 72, they probably would have been much more tolerable levels.
Absolutely.
I had a question, Stuart, from Mark Ray.
Yeah, saw that. Go ahead and ask it out loud.
Yeah, I'll ask it out loud and anyone can chime in. Can we overcome oversized HVAC systems? I know we talked about oversizing. Cooling can obviously have a negative effect, but so can you overcome oversized HVAC systems adequately during less than peak days with VFDs and modulating chilled water control valves?
Yeah, so the whole question was important because it mentions chilled water. If you have chilled water, and assuming that you're not doing a temperature reset on your chilled water, you actually have a lot of, it's a great system to have for systems where you have a high turn down. Packaged DX equipment, so that would be, kind of your standard packaged rooftop equipment that a lot of facilities get served by. Those you're a lot more limited on what you can do on turn down. So if they are oversized, it's a real problem. And reheat is not an energy efficient answer, but sometimes it's the most sensible answer to an already installed system that's too big.
I feel like we have a lot more options with chilled water, like you said, Stuart, because you can, if the system can handle it, and if not, then you can add glycol and stuff too. But if you lower your chilled water set point and lower the discharge air temperature coming off of that cooling coil, a lot of times you can get more moisture out of the air, right?
Yep.
The chat came up kind of along the same vein. So for larger HVAC systems, are there routine adjustments that need to be made during the summer months? Are facilities aware of this, and can they do them themselves, or do they need like a dual temp or company to come out to do that?
I would say in a properly maintained and designed system, no, but we do have a lot of buildings we take care of where we do have to make routine adjustments based off of whatever's going on. And we have a full building automation department. So what we've done at times too is engage them to help automate that for the facility. If they don't have the capital to be able to spend hundreds of thousands of dollars to put in the HVAC equipment that can handle it, or spend millions of dollars to fix whatever the building issue is, tens of thousands of dollars, we can put a control sequence in that can take care of some of those manual adjustments. Doesn't fix the underlying cause, to Stuart's point earlier, but it kind of makes your life a little bit easier.
Yeah.
And a real simple thing is, and some people don't like this. I'm a weird one. I like 75, 76 degree space temperature. I'm happy as a lark sitting there at my computer. If I get in a panel discussion and a little hot under the collar, maybe that's too hot, but trying to maintain 70 degrees on an interior space in the summertime, man, that's tough.
Yeah.
That's tough. You're going to have trouble with most systems maintaining your relative humidity below 60% when you do that.
Well, what does Kutztown at Penn State? I mean, I know a lot of campuses have kind of set parameters of the heating and cooling season. Like, isn't the cooling set points usually
72. 72.
72 at Kutztown?
Yep.
Oh, Penn State. Do you guys know that, Ray or Neal?
Yeah, we're 75 cooling, 70 heating.
Yep.
Depends
And
on
I think in most cases, you have a hard time getting occupants in a typical office building to be happy a whole lot hotter than 72. You're gonna have enough people who really want it to be there to be comfortable. But man, if you're trying to be 70 or sub 70, you're gonna have a hard time.
Yeah. Let me do this last poll because we are at 2:45. And Dakota, do you still need to leave at this time?
Starting to close windows down here. Yeah, I'm gonna have
Okay.
to get out of here shortly, but I'll hang out for the poll for a couple more minutes.
Well, you go when you're ready. But again, thank you for joining us. Your input obviously was very, very helpful to me and hopefully everyone else as well.
Thanks
Again,
for the
on the-
invitation.
Yeah, absolutely. So last poll here. Launch. All right, humidity problems most often brought on by multiple choice question: building envelope, groundwater, inadequate HVAC.
This is
piping
not so
failure.
much a quiz. There's not a right answer. It's
Nope.
just, when you've discovered what the problem was, what was it?
Yeah.
And it's not uncommon for it to be more than one. So this is interesting. Building envelope and HVAC are at a pretty strong lead.
Mm-hmm.
And this kind of goes back to the inadequate HVAC side. I'd say when it's a cause, it's because you have an amount of ventilation air that's required for the building that you're not treating correctly. A lot of other times HVAC can be your solution. Maybe it's the cheapest way to take care of a poor building envelope. And you might need to make some adjustments to your HVAC if it wasn't sized for that deficiency that the building has.
Improperly maintained HVAC equipment is something we see all the time. And I would say that probably falls under that inadequate HVAC. People blame the HVAC equipment for it, but we come in and we find we have a bank local to us. It was having issue after issue after issue. They called us, they had us come out and look at it, and the filters were disgusting. The coils were disgusting. The belts were loose, and the building was only like a year and a half old, but nothing was ever done to it. They just didn't know. They don't have facilities people. And we cleared all that stuff up. They're like, this HVAC equipment can't handle it. It's hot out and it can't get the humidity out of the air. We cleaned it up and got it all maintained properly. And they're like, oh, wow, building does work okay.
Yeah, we're
So that'll be
fortunate.
my parting gift.
Yeah.
So
Thanks, Dakota.
maintain your equipment. Thanks
care.
everybody for having us. We
Take care, Dakota.
appreciate your time. Sorry I have to
Right.
cut out of here early,
Yep.
but have a great day.
Oh, thanks, Dakota.
Yep.
Yeah, so inadequate HVAC and building envelope are the two main ones.
Yeah,
Bill, you were getting ready.
we're fortunate enough at the university to have a PM program where our guys, and I'm sure Penn State has the same thing, where, different times of year, ticklers will come up, change these filters, do that, check this, we have that benefit here. And we also have a guy,
Gotta have a guy.
we have a guy that sits at our BAS computer, and that's what he does all day long, And then he gets little wrenches thrown at him like, hey, Glenn, COVID, open everything up 100% outside. Oh, no, now what do we do? You know what I mean? So, yeah, we have a guy. So.
Good to have a guy.
I'll share these results quick. Go ahead, Ray.
No, that's what we're looking at Penn State. I mean, with COVID, we've maximized all our ventilation in all the
Yeah.
buildings.
Yep.
I mean, even to the point of, if the air handler, it opens it to the point that if the air handler can't maintain discharge air temperature, it'll start backing it off,
Mhm.
you know, but we're over ventilating. I mean, before this, we tried to do everything we could to save energy, but now that's out the window. We're ventilating and we're doing all we can just to try to make buildings as healthy as possible, but that ain't helping with our humidity issues. And
No, no, not at all.
Test scores are going up.
That's right. Better ventilation air, right? Yeah, that's the other thing. It's, you know, good that Ray mentioned about energy. You know, energy drives us in the opposite direction a lot of times
Oh, yeah.
than healthier buildings.
Yep.
You know, healthy enough, I guess, is the right answer. We're shooting for healthy enough, right?
Yeah.
Because we could spend a lot more energy, and we could spend a lot more first cost on more systems, more components, more annual operating expenses. I shouldn't even say more components, right? It can still be simple systems, but they can use a lot more energy and give us really well ventilated, really spot on humidity control and so on. But we're always, you know, there's always some give and take on that energy.
Mhm.
If you look at the ASHRAE ventilation standards over the last few decades, they've risen and fallen with the energy costs, you know? So, you know, it will be interesting to see how much of this ventilation air, you know, we're going to go back to as designed conditions, I think in a couple of years, but it's open to conversation up about it for sure.
Mhm.
I have another quick one that, you know, I know we've answered. There was a couple options thrown out there, like dehumidification units. Are there any other low cost options? You know, Bill, early on in the conversation, you did that first floor. Then you said about the second floor is going to be another couple $100,000. Are there any low cost options that, you know, you've seen or heard or done?
No, really, like Neal said, go out and buy a bunch of DUs.
Yep.
We got a room full of DUs and we just they're on wheels. They're basically fish tanks, you know, drag them out, stick them in the arena, stick them in Rickenbach, stick them in, you know, DFRAN, in the lower level DFRAN. And now we got a PM because they fill up with water and you dump them out. Fill up with water and you dump them out. I mean, it's a cheap, quick solution to a high humidity issue in a building that can be dispatched, you know, relatively quickly without a whole lot of cost. Just somebody's got to babysit them. So,
And my guess, Bill, is you're using those for low occupancy summer times in those types of spaces where, you know, the noise from the dehumidifier doesn't bother people because you're not using them. It's really there as a preventative maintenance kind of item for a low occupancy space. Long-term solutions, it was really hard to get cheap ones. You know, probably the cheapest is some form of reheat.
Right.
It's rarely a cause of not enough cooling in these humidification issues or dehumidification issues. So some form of reheat or added heat to the space, you know, that's a good way to allow this system to dehumidify more throughout its life cycle. That's more of an energy cost. They're fairly cheap on first cost, but you know, you pay a lot on energy for that. But yeah, it's tough when a building's not designed right for some reason or another, whether it's a building envelope deficiency or a poorly designed mechanical system for the ventilation area requirements that you have. It's not cheap to fix permanently. So
what is reheat? Someone asked that. That's a good clarification.
good question. So fundamentally, what reheat does is we talked about the cooling coils being oversized. Driving the space temperature down doesn't help, right? But you still want to drive moisture out of the air. And the way a mechanical system takes moisture out is to drive the temperature down so that you have condensation on the cooling coil and it wrings the air out. If you don't want to drive the space temperature down, you have to add some heat back into that air. So reheat can be at the unit level. It can be in the VAV box, like which is a zone control level, or it can be within the space. If you put them in the space, you know, set them right beside somebody, they're not going to be happy. But if you add heat to the space, the system's going to have to add cooling to maintain space temperature, and that'll help dehumidify.
Yep. If you have a dehumidifier in your basement, as your humidity level goes up in your basement, put your hand next to your dehumidifier and feel what you feel coming out. You're going to feel warm air coming out because it's heating up the air to dry that out. So, yeah.
It's like my home hot water. Thanks, Stuart, for that recommendation.
Yeah.
The heat pump system, it keeps my basement relatively low in humidity.
Yep.
All right.
Introducing reheats though can be like Stuart said, it can be a costly. I mean, do you go electric reheats? Here at the university, we have central steam. So we put summer boilers in our buildings, gas-fired summer boilers. And that's how we get the hot water necessary to serve reheats, for our classrooms and that type of thing. So,
Yep.
yeah.
Yeah, if that's done with the original system, it's fairly cost effective, still more expensive than electric, but a lot cheaper on operating costs than electric, which is why we do it. But to come back and do that later, that's tough. Yep.
It is.
So, well, hey, if the panel or attendees have any specific questions, quick fire them away. We've got 5 minutes here yet. If there's any tidbits of information you'd like to hear from these guys or curiosities that they mentioned that you'd like some more information on, now's a good time to ask. Well, I don't see a barrage of questions, so let's not make this a painful exit, right? Thanks everybody for your time. We appreciate it.
Thank you. Thank you very
Thanks
much.
Bill and Ray and Neal for joining, and Dakota, if you're listening to the recording, which I'm sure you're going to do that later tonight. Thanks for joining us and giving your input, and thanks to all the attendees too.
Yeah.
Thanks, guys. Appreciate it.
Thank you.
Been a pleasure.